it's pretty exciting to see, you know, the computer science and the hard rock science, the people studying paying, you know, really think about the ways how we deal with the data science and how we deal with the data problems that looks like almost every tree, every profession is you know, facing. So what my presentation is a little bit different from the, you know, the art science and the computer science field. So my focus is on the librarians, and I think a lot of us, a lot of you sitting here today are actually working in libraries. So this is what I'm going to report is actually the experience that we had in the past 2 or 3 years, well, more than that, in trying to develop the curriculum to train librarians to become the, you know, to have the skills and the knowledge, work with scientists in managing their data problems. So before I start introducing that, I think I need to mention a failed paper attempt. But you know, when we first received the grant from IMS to train e-science librarians, and I think my colleague suggested that I should put together a paper trying just to address what is the e-science librarianship, what is a e-science librarian. So I tried that, but I didn't fly because you know, part of it is just lack of time, and the others is everything was just starting, and I'm not sure where the direction, you know, which direction our project will be going. So at the time, the only thing that I did write is the 5 notions of the e-science librarianship, and then now when you look at it, it seems some of it is a little outdated, maybe. So if you look at the first one, first notion is the e-science librarian should be part of the team that transcending disciplinary boundaries. So this is mostly from my own experience as well as from my Cornell colleagues' experience, because we have this close you know, partnership with the Cornell librarians, which you know is led by Gail Stanhart, who's in the audience, and a few mentors also. So this is one, and second, the consultative role for librarians. You know, when students and faculty come to librarians to ask about data discovery questions, or which data set should I use, how do I locate them? And this kind of question cannot be answered like, oh yeah, you go there. It's not as simple as the traditional reference questions, but it's more, you have to questioning the students and through the interactive process to finally identify what is exactly the users or the student, the faculty's need. And third, of course, active, the e-science librarians should be active players in data curation, and I think this have already a lot of examples. I don't need to say more. And leader, being a leader in e-science initiative. This is quite broad, but you know, whatever it means, I guess you can interpret it in your own context. And finally, proactive training for data literacy. And this is important because of, you know, from our own experience, the faculty and the graduate students we talk to, we work with, usually know little about, you know, how to manage their data, what kind of tools they're out there, and methodologies and all that. So training is not just train ourselves to become data literate, but also train the faculty and the students to be literate. I think this echoes what Kirk and Peter mentioned about data science should be a skill as natural as you use Microsoft Office, that kind of level. Okay, so in the last few years, our school has received funding from NSF as well as IMLS to train data. One of the projects was cyber infrastructure facilitator, which was led by another colleague of mine, Jeff Stanton. And for me, myself received two. One is from NSF about the science data literacy for undergraduate students, but the anecdotal story proved that undergraduate students are not very perceptive about the things we try to teach them in the science data, but graduate level students better did better than the undergraduate students. But anyway, this one is what we are going on, and the second project was funded by IMLS, and Cornell is our partner, and Gail, and her colleagues developed a great mentorship program, and she reported in her poster yesterday. And we also have two of our eScience fellows in the audience, Chris and Gisela over there. Yeah. Okay. So before I talk about the curriculum, I want to mention a little bit about our overall learning objectives. I think when we wrote the proposal, we promised to IMLS that we'll do outcome-based learning assessment. So, and in order to, do that, we do need to specify what our goals and objectives and what can be considered as learning outcomes. So the overall learning objectives include cover 4 areas: ability to articulate e-science and to plan and develop e-science librarianship projects. And second, competency in science data management, competency in cyber infrastructure technology. So the first is about science data, and second is about science data, and third about technology, and finally the soft skills, communication, collaboration, all that. So I'll have more detailed bullets here if you look at it. So in this ability to articulate e-science and to plan and develop e-science librarianship projects, this learning objective was based on our research and interactions with the practicing librarians, especially in the last couple of years. I've been interacting with, besides the Cornell librarians who have a good reputation in data curation, data, institutional repositories, and the VIVO, and it's also well known in our field. So, and so I think in this, we developed this, so we think based on what's going on in the field, and we expect our students to be able to not just do things, but also to be able to communicate, to advocate for, for developing data services, to support research, to help faculty and the graduate students dealing with their data management problems. So all these, these bullets are drawn up to have this general skills we expect the students to have. That's the first area, general, planning and that kind of. And the second area, competency. You see a lot of, words. We repeat metadata a lot here, but metadata is not just cataloging, but metadata includes actually a lot of stuff, including what Peter earlier mentioned, semantics, and as well as not just manually to create metadata, but also trying to use technology to automatically extract metadata from data set, from the documentations that come with the science data. So this area is address the data management and organization, and it's the foundation for the for other activities. And of course, technology, we can always we cannot we cannot do we cannot manage our data well without technology. But in this, the technology is not just computer systems or databases, but also we need to understand how this applies to the science research life cycle and the data life cycle. So there's a lot of those stuff. And finally, collaboration and communication, the ability to pitch to your administrators and to win the support to develop new services. And because I think a lot of us, you work in the libraries and you know how budget cuts and how there are some libraries even talking about closing physical libraries, and so there's a lot of changes, transformations occurring in the libraries, in libraries. So we do need to think about those communication and collaboration, coordination skills in order to be able to justify what you're proposing to do. So curriculum, and in our e-science librarianship curriculum, we the first one we taught is the scientific data management. This course was actually developed from the first scientific data literacy project, and it was taught to both undergraduate students and graduate students. But we discovered it was not, undergraduate students were not very well prepared for this level of knowledge. So we modified, updated to teach the graduate students. And this course is now being taught online. And this is the first semester. This is the first time we teach this online course. And of course, there's a lot of tutorial and those hands-on stuff involved. But at the same time, we're trying to figure out the theory about data. That's another. And the sub-infrastructure was taught by my colleague Kevin Crowston. And the data sciences is the capstone course that we are teaching now. And what I want to mention in particular of this course is that the reason that we call it a capstone is that we are bringing everything, the technologies the students learned and many other stuff, okay, so together. But at the same time, we also discuss how to build communities of practice, how to institutionalize data services, and all the strategies. And so those seem to be, I think from our from the students' feedback, we had the same issue that students want to do hands-on, want to get some technical stuff, but we keep teaching students about the theories, principles, and not enough. So how to keep a good balance between the theories and the hacking part? That's a challenge, and I think we learned a lot of lessons from this process. And of course, there are other classes, and databases is a required course, by the way. Okay, so these courses, supposedly mapped to our learning outcomes. And I think I'll go quickly through all these because we don't have, I don't have much time left. So in there are a few themes in the whole curriculum development process. The first theme is building fundamentals, which include on this overview of e-science development and case studies and actually doing it, and also let students understand what, the things as basic as data formats, data processing levels, and what kind of data formats in science there are, and also understand processing the relationships between processing levels, data formats, and the data collections, and how these things contribute to metadata, and how they are related to metadata. And we emphasize the scientific data literacy, because this data literacy is not just for science students, but also for librarians who are going to work with the scientists for their data management problems. The theme two is analysis and generalization. And from all the projects and internships and the activities we did throughout the program, and we constantly find ourselves doing requirement analysis, workflow analysis, data modeling, data transformation needs analysis, data provenance needs analysis. So there's a lot of analysis involved, and this analysis not just for the sake of analysis, but we also need to generalize through our analysis, generalize some patterns, generalize strategies that you can use to deal with the problems. So, and theme three is the third theme is collaboration and communication, which has proven to be extremely important, because all these are new for libraries and even for universities. And if we want to build infrastructure in the institution to support e-science, to support data science, then we do need to have data repositories, those tools like yesterday, a lot of great presentation has introduced those things. I think with some good collaboration and communication, we can set up those infrastructure services for libraries to play an important role in supporting e-science. Finally, our school now has officially approved by the New York State Board of Education the CAS in data science. It's not a degree, but it's a certificate program. We require 2 courses, database and applied data science, which is the scientific data management, which will be revised as applied data science. What is applied data science? It's me. Yeah. But we'll figure out, and this program will have 4 areas of expertise, and students can choose any of, from any of these tracks to build their skills. And I think that's the last one, our project website.